All right, we're back. It's COMP228. It's week 5, lesson 5, part 3, and it's Java programming, right? And last 2 videos we talked about inheritance, object-oriented programming inheritance, and now we're going to talk about object-oriented programming polymorphism and interfaces, right? So it's nothing that you haven't seen before. And again, for those people who are watching away or online, we do have a GitHub repository here. If I go to see if I can go to Centennial. I do have a repository for today, which is, if I'm not wrong, called, did I make it? Maybe not. Let's go in and look. I think I did. Lesson 5, but let's just see. Maybe it's just because it's so new. What the hell? I meant to do one of those. And wow, that's weird. GitHub.com and Centennial College is what I want to go to. Yay, okay. So yeah, there's a lesson 4, and there should be a lesson 5 if I search for it somehow, unless I erased it. I don't see how, but COMP228, lesson 5. Okay, maybe I put it somewhere else. Let's see. I have a way of doing that sometimes because I have so many different places I'm going. So let's check my own account there. I'm trying to stay away from that so that you guys are separate, but you know how it goes. Sometimes I get it right, and sometimes I don't. Yep, it's here. So it's under my last name. That's why I'm trying to avoid my last name because my last name is really long. What I'll do is I wonder if I can fork myself. Let's go into my organization and do it. Let's see if I can do it from there. So I go into my organization. So I'll go into Centennial, and I'll just fork it there, and you guys can see it from there. Centennial. And I wonder if I go in as because I'm in my organization, if I search GitHub for COMP228, let's see if I can use lesson 5. And yeah, everyone else has it too. There it is. Look, it's me, right? And unfortunately, it logs in as me, and if I fork it, I'll fork myself. Watch. Oh, wait, I can choose where I want to put it, like in Centennial. This is a problem, though. So if you see it in Centennial, it won't. If I fork this thing, it won't update, right? So just fork it. If you go into Tzliopoulos, my last name, .com228 lesson 5. Eventually, I'll get this right. I've been trying to create these new organizations, so that way it separates the colleges and my name, right? But right now, it's under me. Okay, it's just me rushing to get this done. All right, so I've got my lesson 5 up there, and so let me post that on concept board for you guys to find that. So if you guys, that might be easier for you guys to do. So here's conceptboard.com, and by the way, I've changed my concept board because someone drew all over it. It is what it is, you know. I know people play around. So there's a new board. I'm gonna make a new board called. Rename, we're going to say COMP228, right? There it is, and we'll share it here on, we'll share it on Twitter, right? And we'll say, join my concept board for COMP228, for COMP228. And once that's done, you should see that on Twitter. And then you should have access to my concept board. If I go to the sticky note, and here it is, I'll just go in there and double tap in there and go COMP228, and then we'll say Java programming. And we'll center it, do a few things, just administrative stuff. COMP228, and today we're talking about polymorphism. And interfaces tonight. That's what we're talking about now. All right. Okay, so I'll publish my GitHub in there. So my GitHub is this. Just so if people want to follow along on GitHub, they can. I'll make it a little bit bigger so you guys can see this. There's my link to GitHub. Okay, it's there. Okay, so this is cool. Let's get back to the real stuff. right? So we're going to pull up our a little PowerPoint presentation. Here it is. Now these PowerPoint presentations have been converted to PDFs, and the PDF version is up on eCentennial if you want to go follow along. Again, we're talking about the concepts of polymorphism and so on. We're going to get into this as, and the Greek word, I got to tell you the Greek word again, for those people who missed it in C#. The Greek words, poly and morphi, right, which is the Greek words. Poly means many, morphi means form, many forms, many shapes. And that's what polymorphism is, right? It's, it allows you to change the shape of your class, right, by reusing it in a nice way. We can override. The way we do that is we override, and I use that decorator, that class decorator, at override a lot when it comes to overriding our methods and so on. One other thing we do with polymorphism is we also talk about abstract classes, which we're going to get into in a bit. And we're also going to get into not just abstract classes, but also interfaces. Because remember, all we can do right now in most programming languages with object-oriented programming and design is we always use single inheritance. Okay, we can't do multiple inheritance. It doesn't really work for most of our classes, right? Multiple inheritance. So we conquer this by using things like we talked about last class when we were together in the morning, like composition, right? We use composition, which allows us to use other classes as objects in our class, right? So we make our classes more powerful, more useful, and we've done that already, right? But if you look at our last example, which is our lesson 5 example here, remember what we did, just to recap, we have a bunch of different classes. One, our program is just a little driver that we're using right now. We have our person class, which is actually a class. I'm going to convert this into an abstract class. We'll talk about that in a second. We have a resident class, right, which is a derivative of the person class. And we also have an address class, which is basically a class on its own that allows us to create an or hold or contain an address or multiple addresses. We have one method in our address class called toString, and I want to make another method in our address class called, add an address or move, one of those kind of things. We want to move from one address, move or change, probably one of those kind of things. So we want to change our address. How do we do that, right? Let's go into that now. So I want to change my address, right? That's the first thing I want to do. Can you propose on concept board, if you wouldn't mind, change of address method? So we're going to call it change, right? I'm going to start typing it out for you. So it's going to be a public method, and it's going to be, it's not going to be, it's like a setter, right? It's not going to return anything, so it's going to return void, right? And it's going to be called change. So we're going to change our address. Okay, and what would this method have in it? What would it include or not include? So there's my public change method. So let's go on to concept board. Can you recommend what I should put in my change? I'm going to change my address here, right? I have an address. I get my address from my constructor just to follow up. When I create a new address, I get my address to my constructor. I overrode my toString function so that it prints out or outputs the output of my address. Now I want to create a way of changing my address because I'm going to move a lot, right? As a resident. All right, let's try this out. So I'm going to save everything. I'm going to go back to concept board and see what you guys got. So I got a bit of a thing here. So I got a street numbers, string, street name. Okay, this is just the stuff I got there. All right. Public void change, and I'm asking for the same things. That's good. Okay, what else? Anyone else have any suggestions? So I'm getting those. Those are coming into that's the method header. So my method header includes all those things. This is good, right? So I'm going to ask for these things to change. And what do I do within my change class? Actually, there's a bit of a hint. We've kind of already done this one time. It is. We've already done this thing. Why would I want to include a change class inside my, or a change method inside my address class? So if I go back to my, I already got this in my resident. My resident is actually sets the address. Set address is what this thing does, but this is too wordy for me. I'm actually accessing my address, right, itself, and I don't want to do that. I want my address, the address itself. I want to send this to the address class to do it for me, right? And I'm doing it here, and when I do a new address, I set my address for the first time. Well, I want to do this. I want to keep my set address because for the first, I want to set my address, but I also want to change my address, right? So in my resident class, I'm going to use the change address method. It's going to have its own change address method, which is actually going to get a, it's going to use the address.change method to use that, right? So let's write this thing. So it's like this. Might as well just copy this, right? Just because this is how easy it is, right? Copy. We get some duplication going on, and that always means that we have to do something different. So I'm going to put it underneath, just so I don't kill my signature here for a second. Here's my set address. I'm going to copy all this piece, right? This piece right here. I'm going to cut it. I'm going to put it over here like this into my this piece right here, and paste. All right, let's see if I've got part of this correct. I may kill this piece. And I've got some issues, right? So I've got this address is equal to new address. I don't need that. I need in here this setting. I need this address, almost this part here, this street number, almost like another constructor. I'm calling the constructor again, right? So I'm going to do one of those. Copy this piece, copy this, go over here again. You're gonna think about this for a second. So I got duplication, right? Is this wrong? Duplication. Yes. Okay. What should I rather do here? It's not technically wrong, but I'm duplicating code. When I see the same lines over and over again, like this, right? It's almost like, and I have these are public, right? This is my constructor. It's almost like I want to call the same method twice, right? I want to call it here in my constructor, and I want to call it here in my change. So almost like this has to have its own set address or initialize address itself, right? Which should be probably a private method that you can't access, right? So I probably want to do something like that. So this is my constructor. Here's my public two-string method. Maybe I'll make some private methods down here. I'll show you what I'm talking about. Actually, below my change method. So let's go down here. I'll make a private void method that does. We'll say that it the set method, right? So we have a set method. The general set method is private only, and because it's private, I'm going to make it an underscore set, right? My set method, which is basically going to say one of these, right? I'm going to pass into it though all these values, my string, my blah blah, all this stuff, just like I normally have up here, my this thing here, and all of this one time. You'll see now you're going to say, well, you're duplicating one more time. What's why? So here we go. Here's my set method, right? My set method. I got my change method. I got my constructor. They're all the same. But now what I can do is I can do this. I could say, let's pass into use my set method to set everything else one time. I only have to write it once, and then I just have to call my set method like this, this dot underscore set, right? And then it's asking for my street, my name, blah blah, whatever, and I'm going to pass in there these things. And actually, I can leave it as is. It's good, right? And the same thing goes with here. In my constructor, I can do the same thing in my constructor. I just put the set method in here, right? So my set method sets it's a private method that sets, that's not going to be shared, right? So private method, right? And then this set method, it's a general address set, if you will, or initialization, or what you want to call it, or reinitialize. And it's going to it's going to be a private method, the inner workings of my address class. So I can set it with my constructor, and I can also use this public change method to change my address again, right? But it's still going to call the set method twice. So I don't really duplicate anything here. My duplication is reduced. And it also gives a nice interface for my address. There's other ways to do this, by the way, and we can think of other ones after. But here I'm setting it. Okay, good. Now I've got my set method. If I go back to my resident class, I don't really have to do what I'm doing here, right? So this set address, that's good, but what I want to do now is I want to do it a little differently. I have my set address, this a little bit bigger so you guys can see. I have my set address which is my resident class. But what I want to do, and this is available, this will be available in my my driver class, right? I never want to call from my driver my address directly. I want to do it here in my resident class, right? So how do I do this? What I want to say is shorten this thing up. This new is the one way I can set my address, right? I want to do this new thing here. But when I want to change my address, so here's this, I want to do my change address here the same way. I'm going to kind of copy this thing and put it over here. And you're going to see there's very similar things here that I'm doing between one and the other. Set address, and I'm going to say a change address. Here's my change address. In my change address, I don't have to reinstantiate my address. There's no need for me to make a new address. What I need to do is use the change method of the address, like this. And I can get rid of all this. Right? So I have my change address. My new address actually uses the new keyword. That's kind of, I set my address for the first time, right? My change address, what I'm doing is I'm moving. Right? I'm changing my address from one address to the other. I can't do that with my set address necessarily, because I would create I would instantiate a new object this way, right? But now we're going back to this duplication stuff. You look at it and you're like, could this be done differently? Can I use one to set or change my address, right? To reduce code a little bit, right? Because it's the same, set address and change address. Actually, it's identical. One is using the constructor for the first time, and the other one is changing my address again. Well, I could make it smaller. I could, but I don't really want to. This is a different thing. When I set my address for the first time, I need some way of setting my address the first time to get that information, right? And then my change address, I can't call my constructor again because it would kill. I mean, I could, but it would kill off my address and redo it, right? Effectively, it would be just like doing this. But I don't want to, just in case. I don't want to destructively kill my address class whatsoever. Okay, so kind of duplication here, but it's okay. It works. How do I then change my address in my program? So here's my program. I've set my address here, to 55th Street, and then I do a system.out.println. Let's do another system.out.println on the top just to give myself some space. Out.println. Again, next when we come back from break, we're going to talk about UI. So we're not going to do any more of this command line stuff or which we call console stuff, which to me is just a lot easier. I don't know about you guys, but console is always a pain in the ass because you can't format it, can't make it look nice. There's all kinds of other bad things. Okay, so there's my /n, so new line, and so two new lines there plus the address. And you know what? I'll copy this whole thing again. Instead of set address, I want to change address. I'm just going to kind of do the same thing. Put it down here. Instead of set address, I want to change address. I can do that. Instead of 55, I want to go to 44th Street. Why not? In Toronto. 44th Street. I went from 55th Street to 44th Street in Toronto, and I want to print it out by using the resident.get address. Right? So very, very simple. Let's run this thing and see how it goes. See what I get. All right, so there it is. So I go, Tom is eating, because I'm resident. Even though he's eating, he's also a person. And here's my address, 55th Street, and then I change my address to 44th Street as an example. Hey, wouldn't it be nice if I say address change, if I'm changing my address? How would I affect that? So when I change my address, when I call my change address, it says change to new address or something like that instead of what it says here. Not that difficult to do. If you think back, we go to my address. Here's my address. And inside here, I have a toString that I've also included in this output, right? So if I call, I can set a flag in here as an example. So if my address has been changed, then I change what it says here in my toString. Okay. Otherwise, so I say this, Or if my address has been changed, I say something else. Okay, let's see if I do that. Okay, so first of all, we need some kind of flag. In my private, you know, is changed or is new or has changed. So we're gonna make a private Boolean, right? Private Boolean variable that is, you know, something called has changed. We're gonna make it equal to false. We're gonna set it as false at the beginning. So my private Boolean has changed with an underscore has changed, right, is false starting off, so it hasn't changed yet. And what I'm going to do here in my toString is I'm going to pull for it. I'm going to say if, right, you know, if it has changed, right, so that's true, has changed. This dot has changed. Okay, this dot underscore has changed. If it's true, I can just put if has changed, right? Then I want to do something different than what I'm showing you here, right? So my output is going to be different. Else, it hasn't changed, and therefore I want to do this, right? This this address here, right? So address hasn't changed. So I want instead I want to put this as new address, right? So I'll put this in here and go new address, right? There you go. So I'm checking if it's changed, right? How do I, now right now it's false, so it's never going to change. How do I make sure it's changed? Well, when I access my change method, then I set my flag. So forever, right? Once it's changed once, it's always going to change, right? You can never go new. So if I say this dot underscore changed, oops, has changed, sorry, is equal to true. I set that flag to true, right? So the address changed, right? If the address is changed, it's a new address. Otherwise, it's an old address. And you know what? Most often, it's going to be a new address, right? So now my output, my toString argument is going to change depending on if my address changed or not. All right, let's go back and check that out. You guys got all that? Ravina, no? Yes, kind of? All right, I'll populate it on GitHub in a second. Okay, so now let's see how it works. So I'm going to say run, and here's my address, and then new address. Did I make a mistake? I did. I put a space in between new. See that, try that again. New address, there it is. So address and new address, and it can tell that this is a new address. And if I change it again, it's still going to be new address because my address has changed. It went from 55 55th Street for the first time to a new address, which is 44 44th Street. I remember I also put this try catch just in case I've never set my address. I could output a you know, kind of a kind of thing that says is over here, right? It just does what I want it to do. But in my resident class, if you notice, I have this try catch block when I try and get address. Well, there's no address, never been set before, right? So that's why it's giving me this exception, this general exception that says error, address not initialized, right? Or you've never really, you haven't really set the address to anything. That's what it's saying. All right, so here's a question for you. I've got my person class, but my question to you is this: am I ever going to have a person class in real life that doesn't have an address, or that's not even associated with any other class? Like right now, chances are it's such a generic class, person. I don't have anything. I have a name, I have a height, I have a mass, but really at the end of the day, I'm faceless. I don't have a culture attached to me. I don't have maybe other things that are. I'm not a student. I'm not a teacher. I'm not an employee. I'm not unemployed. There's a lot of stuff, and chances are I'm not going to ever instantiate this person class as an object, right? Like Tom is equal to a new person. Never going to happen. I'm going to go Tom is a resident. Tom is a teacher. Let's do one more test here. So our resident is our subclass of our person class, right? Let's make another one, another resident. I want to make two, right? I want to make, we won't go into employee, okay, or non-employee. We'll just say two from here. I want to make two more classes. I want to make a teacher class, and I want to make a student class, just as an example. So let's do that. I'm going to give you a chance to create them, and then I'm going to do my own, and I want you to go up on concept board and see if yours matches with mine. Okay, so people that are watching obviously are going to see what I'm doing, but what I'd ask you to do is try and do it on your own first. Here, the people are in class. If you're watching, try and do it on your own, and then we'll look to concept board when I call it out, and we'll try and see what the differences are. Okay, so I'm going to add in a new classes. So you go ahead and do this, and I'll do mine, but I won't call it out. I'll just show you what I did. All right, so go ahead. Try and do a person class, a teacher class and a student class. For those people who are watching, I'm going to update my GitHub for now. I'm going to go team commit. I want to say updated address class, right? And resident class. I did. Okay, so commit and push. And you should have those changes up on GitHub now. So if you go to the GitHub link, which is here, and refresh, I just updated those things. So that's up on that link I gave you on concept board. So here's my concept board here. Oop. This one. And I want you guys to start thinking about it. So put it up on concept board. Put up your idea of what the student and the teacher looks like. So go ahead. Try and put up your idea of what it's going to look like here when you extend, and what the differences between are just a regular resident and a student. Maybe they have some things that are specialization for the student. And what about the teacher? There's something special about the teacher that he has that's different than the student, right? Okay, well, there should be anyway. Meanwhile, I'll start thinking about it on my own. All right, so let's go into the default package. I'll add a new class. We'll start off with the student class. And we're going to make this a subclass of the resident class. There you go. And if I look it up, resident is in the default package. Press finish. There it is. And I'm going to make a stub. I'm going to kind of hover over here, and it's going to add for a constructor. I'm going to add that automatically in there. Might as well. Do the same thing for my other one. So just for now, I'm going to make my new class that's a teacher or some kind of professor. Let's call it teacher. Student and teacher. And that's also a resident. Here we go. Here's a resident. And we'll make it finish that one. And we'll hover over this one, and we'll say one quick fix to make that one happen. So I've got my teacher and my student classes now. There we go. Teacher and student. They're both types of residents of Canada, right? You might, in the book, it says community member. That's what they're called in the books, right? So all I have here is teacher and student. And now, what's the difference between my teacher and my student? Well, start thinking about this. This is my student class. I will give you some time to do it on your own. Student class. And this is the teacher class. Just preparing for you guys. This is the constructor for here, and my student, might as well add the constructor in there as well. Constructor. So I'm just mumbling here, but all I'm doing is I'm creating some stubs for this. Okay, so let's see what you guys got in concept board now. We'll go back up here, and not too much. Only one of you has added some stuff in here, right? Public class student extends resident. That's good. A student number. I like that. And ooh, we got to be careful with our class. A class array. So classes maybe might be the better way to say it, right? And now it's a class. I have to create my maybe, well, the class array itself. Maybe you want to talk about courses, or that kind of thing. Courses as opposed to classes, because classes. We're using class, it might be confusing for some people, right? So course, someone's modifying this nicely. So a course array, and the course array is going to be an array of courses. So courses would be your course array object, courses. I like this. Let's just start going since we don't have a lot of time. So here's my student. I need to create an array, a student ID. So I'm going to say, here's my private instance variables. And in my private instance variables, I'm going to have private underscore student number. Sometimes they're strings because they may include some other characters as well. And you're not going to add your student number to anything else. It's not. It doesn't have that. So making an integer makes no sense. You might as well make it a string. And I'll call this underscore student ID as an example, or student number. That's fine. So that's one of them. The other one is we want to create a courses array, right? I like that idea. That means that we're going to make a composition. Our student class is going to be a composition of another class that we don't have yet called courses, or the course class, right? So that's how do we do that? So let's right click, add to our new program another class we haven't talked about yet, and we're going to call this the course class, right? The course class is not going to inherit from anything else. It's going to be a Java Lang object class, and we'll click finish. Here's our course class. Now, why am I calling it course and not courses? Well, courses would be the object, an array of course, right? A course array. So that's one. I want to make my constructor, and I'm going to right click here and see what I can do if I go to my source. I go source, generate getters and setters, delegate methods, hash code and equals, generate toString, generate constructor using fields, generate constructors from superclass. I could do that too, but there is no superclass. I don't have any fields. I know I want to make some fields. Let's do the fields first. So I want to go here and go private instance variables for my course class. Lots of classes, eh? This one. And in my private instance variables, I want to add in a class or some stuff here. So maybe my course description, course code, that kind of thing. Might be the two things. Maybe course cost, might be a cost associated with the course as well. Things that you put in your database, right? So let's just assume that that's one thing. So course code would be the first one. So it's going to be a private string value. We're going to call this course. Well, maybe we'll call this code. Right? And the reason why I'm calling it code and not course code is because the class is called course. So it'll be like course.course code. We don't want that. We just want to say code, the code for the course, right? And then private string, we also want a description for the course, right? Course description, course code would be the two things. Maybe the last one would be a private. This would be probably a float or a double, right? So I'll make this double. A private double cost, the cost for the course, right? So we would have our total costs. Okay, so that's some fields. These are some fields. They're private instance variables, right? And now we want to include some other stuff in here. We want to create our constructor from the fields. Let's try and do that. So I'm going to right click. I'm going to go into source, and I'm going to go into generate constructor from using fields and see what it gives us. Hey, there it is, code, description, and cost. And then it says, where do I want to put this after the cost? I want to make my access modifier public for sure. We've got some issues here in a second. Do I want to generate constructing comments? No. Do I want to make a call to the default constructor super? Yeah, well, let's see what happens if I don't do that. And press OK. Yeah, so I don't need to make this, so I probably would have accepted not having that because I don't need that's a default thing. So there it is. So that's a quick way of doing a constructor. This is the, a generic constructor. So here's our constructor for our course. And maybe I can do things like adding and dropping courses, but I'm not going to do that right now, right? Because that's something that I can add to the course class. Right now it's just a container class more than anything else. All right, so when I say it's a container class, all it has is a bunch of properties, but there's no methods. There's no behavior, right, for the course. So I could, if I wanted to make this, do something, it would have a behavior, and then I could add things like course.add, course.drop, right, all that kind of stuff. So I can add and drop a course. But for now, it may not be appropriate for me to do it here, right? Okay. So let's go back and see what the proper thing to do is when I go back into my student. So we'll go back to the student. Instead of a course array, which I like your thinking, how about an array list, which makes more sense, right? Yeah. So that way I can, if I made a course array, I have to keep track of how many elements. I don't know how many courses I'm going to be taking, so it's not appropriate. I want to make an array list. So how would I make an array list of my course? What's my syntax for the array list? Let's go back on concept board. I want to make an array list of course, a course array list. Remember, it's a generic, right? So maybe I can see something in here that does that. There it is, array list course. That's it. That's how you do it, right? Array list course, what's the other side? Is equal to? Oh, private array list course, courses, is equal to new array list course. I like that. If it's private, our courses have to be an underscore. That's the only thing that I would say as a convention. I'm going to copy this one right from here, go back to here, and inside here, I'm going to probably paste this thing. I like this. We're going to get some stuff going on here. It says import array list. Look what it says. Because I don't have an array list, it says import java.util for the array list. That's I need that to make sure my array list functions, or I don't have an array list, right? It's a collection, right? I'm using collections. I'm not going to call it courses like this. I'm going to use underscore courses right here. And if you notice, I'm, instantiating a new array list here right when we create our student class because, and I can do this because, it's appropriate to do so here. What I want to do is I want to add a new course. So if I want to add to the new course, I can say this dot underscore courses dot add, right, to add to the courses. I can add multiple courses, or I can drop. How do I drop? By removing courses, right? I remove courses from the array list. So I can do an array kind of do a plot of how many courses. Well, this is interesting. It rises to, I want to be able to do a toString method that shows me my courses and my student numbers and all that stuff. So let's do a custom toString method. Let's see if I can do that with the generator, right? So I'm going to right click here, and I'm going to go to source, and it says generate a toString method, right? So here's my toString method that I'm generating. Let's see if I can do it automatically. So click. Okay, so it says select fields and methods to include in the toString method. So I want my courses for sure. I don't want inherited fields or methods. I don't care about that. Let's see what it does for me. It says my string format is my default template. There's also, I can edit that, my string format. If I do, I can create a new default template. This is what it's going to look like. My preview is object at class name. This is kind of a high level meta tag of what it's going to look like. Let's leave it as is to see what I get. My code style is string concatenation. I can also choose a string builder format, which is using the string builder class. Very nice. Or I can use the string format, messenger format, right? Let's leave the string concatenation, which is my favorite. String concatenation. And it says list contents of arrays instead of using native toString. And then limit number of items in array collections maps to 10. No, I don't want to do that. And skip null values. So I'm going to press OK and see what happens. All right, so I get this. I get my public. I've got an override in there. I don't care about this, right? I get a public override toString method that says return student ID. Oh, this is interesting. Plus student ID. So my student ID equals plus my student ID plus courses equals courses, and then what's the square brackets? Why am I getting these? And it's just the way I'm formatting it, right? So I'm not going to do this. I'm going to say student ID. So let's redo this thing. So I'll say student ID equals, right? And I can reformat this the way I want. The number of courses. Let's see if I can get my courses happening. Equals. Here's my courses list. Plus whatever. Okay, so I want to see what my course is. Right now it's empty. Okay, so I want to be able to add to my courses. So I need to make a couple of methods to do that. I'm never going to change my my student name, age, height in inches, and mass in pounds, and all that kind of stuff, and my social insurance number. That's not going to change. But in my constructor, maybe what I also want to take in is my student ID, which I didn't have before, and I don't have that as something I'm taking into my constructor. So let's do that. It's one thing they missed. Maybe I missed it. So I want to take something called string, which is a student ID, And now what I want to also do is I want to say at the bottom here, get rid of this auto-generated stub, and say this dot underscore student ID is equal to set my student ID, right? Student ID Done that there. A little bit more of a complexity here. I've got my array list of courses, but I got nothing. I got no courses to add in. So let's add in a course. And of course, how do I add in a course? I have an array of, or array list of courses, and each one has, each item is of type course, right? Which means it's got a description, it's got a cost to it, it's got a code, course code, right? So how do I add them in? How do I create a, when I do an add, how do I add this in?
Courses.
I could. Let's try it out. So but I have to do that in some kind of method to do that. I want to add a course to my, I want to add a course to my thing. So I'm going to call the add method. So let's make it a public method. Public method, which is going to return void, right? And it's going to be called add course. The add course method here outside, inside my student thing. No, public. Let's see if I can type public. And now what I want to say is this dot, I'm going to follow what you just said, right? This dot courses dot add dot add, right? Here's my add, right? And it tells me, there's some options here that I have, right? I can add a course, right? That's what I have in there, right? And except right now I have no courses in there, and that's what I'm listening for a course. That's the one I want, this one. So I want to add a course, right? And if I do that, I'm going to say, well, it's a new. This is where I go into it. Course, right? Here's where if I do a new course, right? How do I do that? What's my course? Well, if you look at the course string, here's my course string that I can add in there. So I just type that in. Or let's go back. So I'm going to add a new item to my course. It takes courses, right? But I'm going to do a new anonymous course. So let's say course. And then if you notice, if I press Control Tab and do one of these, and it doesn't do what I want it to do. So I wanted to kind of give me some code hinting is what I was hoping to do, right? And right now, if I hover over it, it says add arguments to match the course string string double, change my constructor course string. That's cool. Or create a constructor course. That's not what I want. So of course, I just want to add in my stuff here, which is string, my code, my description, and my double. And that's interesting. I have a code, description, and double. Did I make a mistake? Let's go back to courses. Yep. When I did my constructor, it added in some funny things here, which I didn't want to add in. Sorry, modification. Modification, right? Because if I don't do the modification, I'm in trouble. It will be inappropriate, right? Let's go in here and save. And that means that now in my student, that's going to look different, right? Sorry, that's why I wanted to see what it was giving me, right? And there we go. That's better. So code, description, and a cost. Okay, so code. My course code is of course. Let me see. I add in some kind of course code, right? Now, where am I going to get this course code? So it's going to be something like course code, right? So course code. I don't have that yet, right? I also want my description, course description, right? And maybe some kind of course cost. Right? I don't have these variables, but I'm getting them from my add course method. So then I'll say, I'm going to ask for a string, which is of a course code, a string, which is a course description, and a double, which is of course a course cost. Right, so I'm going to get that. I'm going to ask for that in my course, and I'm going to add this new course into my my courses. So that's my add course done. How do I drop a course for my students? Anybody? I've added a course. I want to drop a course. Any ideas what I would do? So let's start scripting it out. So public void drop course, right? And I'll just I'll skim it out there. I'm going to go back to concept board and take a look on your solutions here. So here's this is good. Whoever came up with this one, this array list course, I like this one, right? And why is like I said to you before, I'm going to ask this question again. Why is an array list the proper more of a better construct than an array. Yeah. I don't have a fixed size, right? That's a really good reason. And also, I want to tell you this: quite often, actually most often, we don't use arrays of standard array anymore. If we have a construct like an array list, why the hell would I have an array, right? Typically not, right? Even if I'm reading a database, I'm going to use my array list that I'm going to load my database into, right? As opposed to an array. An array has less. I have to do more work for an array. An array is immutable. Once I define the array size, it's there. It's done, right? So there's less flexibility when it comes to this. Okay, this is interesting. So public void drop course, and then it's course. Remember, it's an array list. I don't have to pass anything to it. Tyler, what would I do if I was going to just drop a course from the array list? What do you think it would be? Not drop. I think it's remove. Yeah. Let's try it out. So let's go back and try this out. So actually a very simple method. So I'm going to say this dot courses, right? Dot, and if I press Control space, try this again. Underscore courses dot, and if you notice, there's a bunch of different things here. If I start typing remove, there's different objects here. I can remove an object. I can remove all. I can remove elf, right? Remove LF, last, or all, replace all. I can retain all. If I just go remove, it returns a Boolean. If I do remove with an index, right? Remove my index and my course, if I kind of go here, it says remove the element at the specified position in the list. Shifts any subsequent elements to the left, right? Index, the index of the elements removed, right? So that's an index. What if I put in nothing, like just remove? Does it remove the last element? I have to specify what element on the list it is. That's a problem. But I drop any course. I drop the last course. What if I want to drop a specific course? What second one? And what am I searching for here? It says removes the first occurrence of the specified element from the list if it is present. If that list does not contain the element, it is unchanged. More formally removes the element with the lowest index. Okay. So how do I search for a specific object? Right?
Courses dot contains.
Courses dot what?
Contains.
Contains. So I can do that. So I do a special object that contains, right, by using the same array list. This is another little thing I can do, right? So let's try that out. So I say courses.remove, and then inside there, instead of an index, I want to remove something that courses. So sorry, this dot underscore courses dot contains, right? Now what am I looking for? Contains something, right? So contains, and I'm looking for some kind of a name, right, for the course. And whatever the course name is, then I'm going to get from my method signature, right? So whatever the course name is, so course name, right? Well, let's see if I can do that. It's pretty generic. Let's see if I can figure this out. So drop courses, I'm going to, it's going to be the course name, or a course code. Say instead of course name, course code. We don't have a course name, right? Arg. It's too loud. You know what? Maybe we need a course name. See, this goes back to redesign. Back to the drawing board. Hold on a second here. So course code, we're gonna make some changes. So private string, and we'll say this, we'll call it a name, a course name. Changes, right? String, name. And we're going to set it here, this dot underscore name is equal to name. So I've got the course piece done. You can make your changes too. And now here in my course, I need to, of course, and inside the course code, I also want to put in, when I do an add course, I want to go string that course name. Sorry, guys. My arg. And same thing here. So course name. Where does it change? Okay, good. Now we have a string that I want to pass in called course name. Course name. And what I want to do is I want to search for this. I want to search for this course name, and if it contains course name, now remember what does my contains method do in my array list? Is it looking for an object? Is it looking for a string? How is it searching? Is it looking for an object like a string? If it contains a string, drop it, right? So let's take a look. If you don't remember what it is, and I don't know what it is, let's say I want to go and do Java array list methods, right? And here's my array list on Java 8, the SE8. And if I look at all the methods that it has here, here's some method summary. Add and insert specified element at the specified position. We just added, which adds an element in a random place. We get clear, we clone, we contain. Retains true if the list contains the specified element. Now our list has multiple elements. We have a description, a code, blah blah, whatever. It's an array of our custom list, right? So this is an interesting thing. Is index, iterator, last index of, list iterator, remove. I want to remove an object. Removes the first occurrence of the specified element from the list if it is present. So a specialized element that we call something. Remove if predicate. Remove all. Remove range. Replace all. Set. Replace the element at the specified position. Sorts. A split iterator. I like that one. Split iterator. And so on. What about the question that I have in my mind, which is an array list the right constructor? Or the right construct for what we're trying to do, right? Hear me out, right? If I had a way of naming each of my objects, right, then it harkens the fact that I would probably need something like a hash table, right, or a hash map, right, where I would have a key value pairs. The key would be the course name, and the value could be a course, the course itself, right? So I could have a hash map with its own values, and that would add in, still a collection type, right? Just trying to think of something here. So let's go, instead of array list, we'll say hash map. And let's go and look at SE8 here to see what it does. So here's our hash map. Hash map has clear, clone, compute, and contains key. That's what I'm really looking for. If the hash map contains a key, right, or contains a value, I can contain a key that has the course code. That key would be the course code, or that course, it could be the course name, whatever I chose to make it. And then from there, I would use an array list, right, an array list itself, right, to add or remove from it. Because it has other things in here, right? It has stuff like a remove element, and so on. I have other kinds of things that I could use. So there's another construct we can use called a hash map that might be able to help us out. Any other suggestions? I'm going to go down to, this is more complicated than we thought, right? Let me go back over here to concept board and see what you guys think. So how do I remove if I just do this courses remove, I remove whatever my last course is, the last one. I can't specify a course because they're all anonymous elements that I'm adding in. I'm not specifying the name of the object. I'm not saying, here's my new object, it's called blah, right? I'm not saying that. Okay, a tuple. I don't know who put that one in. That's interesting. That's an interesting solution. A tuple. All right. Yeah, I guess I could put the tuple, but that's very generic. So we have key value pairs. That's another type of generic. Anyone else has a simpler, more elegant way of doing things? It's nice, but some people won't understand this, and I don't want to do that with. It's almost like, if you look at it, it's almost exactly like a class. And it is. I'm making a class that's a tuple, and I'm using a generic class, right, which is next level of classes. If this was advanced Java, maybe we'd hit that one, right? Yeah? What other things you want to say? Search how? What am I searching? The array, so the component name, the array list object, right? The course.name, if it contains course name, right? Then and we're good, right? I'm passing in a course name. It's of type course. I'm searching for that. And if it contains course name, if my object that I'm looking at contains course name, then I delete it. If not, then I don't, right? So it's more of a complicated algorithm than a one-liner. Let's go back. All right, so this would be good if we just want to remove something. I like your thinking, Ravina, where you can just go contains, but contains doesn't mean anything for us. So how about if we do a bit of a search, right? So first of all, instead of a string course name coming in here, maybe what I want to do is I want to make it, I want to search for, the course name itself is the name of the course, right? So I can do something like this. So how do I search an array list? That's the other question I have to ask you. I want to search the array list for a specific element, right? So I'm going to say, and I can do it one at a time. I can do, like, if the array list is small, right, I can do it in a for loop or a for each. How do I do a for each? I do a for each loop. I'm going to control tab. Here's my for each. I want to iterate over an array or an iterable, which is my course list. Here's my, this is an enhanced for loop. Remember that we talked about before? So for course and courses, here we go right here. So for course and courses, I'm listing through all of my elements, right? Here we go. So for each, this is what this is saying. For each course in courses, right? We don't know how long this list is. It could be 1 element, it could be 10 elements. I want to do what? I want to compare my course name, right? I want to compare my course name that I'm getting through my drop course method, right, to what I see in the course, and if they match, I want to remove it. So let me try this out. Say if course dot, right, and remember the course is of a type course, so it has a name. So if I say course dot name, but see name, unfortunately, in my course method, right, my name for the course is private, right? To make it simple, and I can make a get name. Actually, I will. I'll make a get name. I'm not going to make it simple. I'm going to make it the right way. I'm going to go. I'm going to make a new getter method. So here's getters and setters, and I'm going to make a new method here. We're going to make a new public void method. Actually, it's going to return. It's going to return the name. It's going to return a string. We're going to say get name, right? And what we're going to say here in this public void public method is it's going to return this dot underscore name, right? So it's just a read-only method. It's a read-only. So we don't want to set the course name in here. Read course name. So that's the method that we have in our course list. We open up a can of worms with the course. Teacher is going to be easy, I swear, right? Okay, I'm lying. It's also good. They're also going to have courses, right, that they teach. This is good that we did this though. Okay, let's go back to student, right? So we have our if course dot get name, right? If course dot get name. Okay, now I want to make it equal to. How do I compare two strings together? How do I do a string compare? Yes. Okay, it's built in. It's built in dot. If I go dot equals, this is the problem. I don't have a dot equals. I haven't defined it. But dot equals to what? Another object, which would be the name of the course that I got, right? Okay, so name of the course that I'll leave the object in there for a second, right? And then I want to do something. Right, so then I want to remove the object that I got in here, right? So if course dot get name equals whatever my course is right now, the current course that I'm iterating through the array, and I'm checking to see if this current course, the name for this course, equals to the object that I'm looking at, which is this course name. Let's see if I can put that in there. Course name, right? If that's equal to course name, if my name of the course equals to course name, then I want to remove it. I want to say this is where you do the remove. I want to say then this dot underscore courses, right? Dot remove, and I want to put the object I'm going to remove, which is course. Make sense? No? Probably doesn't for most of you. This is advanced, you know, some advanced stuff. We talked about using this as a for each loop. This is an advanced for loop. We talked about it very briefly, and we talked about some iterators. This is actually equivalent, which is equivalent to a for each in C#, right? That's what this is, right? So it's an advanced, or actually it's not advanced, it's an enhanced. It's called an enhanced for loop, right? Enhanced for loop. And so what I'm saying here when I do this for loop is the colon says this. I say, I'm going to create a type that's equivalent to the construct that I'm looping through that has no index. I don't have an index for my array list. My array list is indexless, right? I could specify an index, like it could treat it like an array, but I don't know which one it is. It's somewhere in my course, right? Now here's the problem with this structure. And can you see a problem with this structure? How about, you know, Tyler, you see a problem with this structure? This would work, by the way. Huh? It would probably work, yeah. See it? So what am I saying here? I'm saying if my course name, I'm using the getName method, equals to course name, which is the name I'm getting in here from my method signature, then I want to use the remove method, right? The remove method of my course's array list and remove the object course from it. The one I'm on, the one I'm on right now. Okay, that's what I'm doing. But why is this bad? This will probably work, but why is this bad? Yeah. Well, they're read-only. I'm reading the value. I'm just getting the value, and I'm telling you which object I want to get rid of. Remember, they're reference types. I'm saying point to this reference and get rid of it.
Can we delete that course code? Because code will be different for each code.
Course name would be, course code might be better, right? That might be, that's a little iterate. That's a little, I like your idea, but I'm talking about another problem, right? That's a problem. That's another problem that I have. You're right. I'm being very simple here. I could do that too, right? But contains, I don't know if that contains would work properly. That's what I'm trying to tell you. I don't know if the contains would work. That's what I'm saying. I think because remember, you have more than one value. My array list isn't a simple array list. My array list isn't just one value. It's not a string, right? It's not an array list of strings. It's not an array list of integers or doubles. It's an array list of courses, right? So I'm using composition here to create a custom array list of objects, right? As opposed to, I'm not making an array list of things. It's a custom type we've created that has 3 values inside of it, or 4 now, right? We have the code, the name, the description, and the cost, right? And it's hard for us to contain a name. What are you, when you're containing a name, that's not correct. It might give you an error. It might not give you what you're asking for. That's what I'm saying. Well, where I see this as a problem, this for each loop is good for students because you only have, what, how many courses can you take at once? 10? Maximum? 7? That's okay. It's a short list, right? But what if it was a bigger situation? If I had a bigger array list, this would not work because this for loop would iterate through each one of them in order, right? From the beginning to the end, right? This is a long list, and they would have to use some kind of search algorithm to find it. Maybe better and faster than a for loop, right? So that's what I'm saying is a problem. Okay, so let's try this out and see if it works. Okay, first of all, I don't have any students. I have a drop course and an add course. Let's see if we get some issues with this thing when we do it. I'm going to go into my program.java, and instead of making a resident and an address for the resident, we'll change this to student. So we'll say it's not just a resident anymore. You know, I'm going to make a new student, right? Which is a new type new student, and we'll say that the student's name is Mike, right? And he's missing some information here, right? He's missing some stuff here. He's missing his age, his social insurance number, and his student ID, right? I think I need that. Yeah. So it's a student ID is a number. So I'm going to say maybe the year. So you know, 15. We'll start off like this: 15, and the some other kind of numbers that come afterwards. Maybe the first letter, first initial of his name, Mike. You're going to start, or his, you know, Mike something else, MM, and then some other numbers like 1, 2, 3, 4, 5. There we go. That's the student number. Simple student number. All right. Once I have that, I have my student ID, and I want to set my address, but it's not a resident anymore. This is I call the student. Right, there we go, student. I'm just rename this stuff. I could have done it. Actually, let me undo that. I want to rename it. I'm going to go refactor rename. So I'm going to kind of go here. Going to click refactor rename from resident to student. There we go. So it's all done. And let's just run it like this without the enhancements. Let's see what happens. Just this, right? And press play and see what I get. So I get Mike is eating. Address 55 5th Street, 55th Street, moving to a new address. And after he moves into a new address, I'm going to add some courses. Right? So let's try this out. So I'm going to say student.add course. I need a course code. So let's add this in. I'll say my course code is COMP100. Right? Or we'll call it COMP101 to make it unique. COMP101. Right? My course name is Programming Fundamentals. My course description is, to me, a little longer. First computer course. And the course cost will be $600. Let's say $600.35. Just because I'm making it up. All right, cool. I've added my courses. And you know what? I want to show my course. So let's see if it works. I go student dot toString. That's not right. Student dot. How do I print out my courses? Do I remember? Let's go student. I got toString and I print out my courses. Let's see if this works, because remember we tried this out last time and it just shows courses, and that's not good. By the way, I should probably change this to this dot and this dot for student ID. Because I need my student ID and my courses, and this doesn't. I guarantee you, it's going to give some weird results. Let's see what it does, right? But let's try it the way that they give us from the generator, all right? So let's go back to program, and I want to say student.toString. Okay, my student.toString returns, if I'm not wrong, returns a student. And I want to print this out, so I'm going to kind of use some kind of system.out.println to do this, right, with. So it'll be something like this. It'll be system.out.println, and inside there I'll put in student ID, right? There we go, student ID. Test it with. And let's try this out. All right, so far no issues. I have my student number 1, 2, 3, 4, 5, and my courses is course at 7852E922. What the hell is that? It's a course, right? But I don't. This is the object number, right? This is the object that I'm printing out. I don't want that. Yeah, that's what this is giving me. This is the object. I want to go through each of my courses. Let's go back to the drawing board. Just like Wile E. Coyote says, back to the drawing board, right? And we'll go back to student, right? And we'll see this is neat. I like this piece, but I want to create that output again, like that output idea, right? So I'm going to say one of these things. I'm going to say a local variable called output that I want to kind of use as a.
Is that a toString to course?
No, not really. You're talking about going to courses over here, this course, and going to toString here. I could. That's a smart thing to do. But this would only print out one course.
No, but then it would just look for
one course. Course is one course, right? Student is where I really want to add it in. I want to say, here's my output. And let's not do the return yet. We'll do the return at the end. So we'll say, let's get rid of that return and go here to this return, the total output, whatever that's going to be at the end, right? And in here, in our student ID, we'll say output plus equals to the student ID. And I don't like the way it's formatted anyway. So let's just reformat. So I want my student ID. So my student, whatever the name is. And let's put my name in there too, eh? Why not? The student name, and then plus the student ID. So I'll say this dot underscore name, because I have access to that, plus, maybe in before that, I would probably put in something like student name, right, plus this dot underscore name, and then maybe the student ID afterwards. I'm going to make some spaces here for a second. So just, I'm composing, guys, so you know what happens when I compose. I'm going to mess things around. So here's my student ID. Let's get rid of that equals. I knew it was going to fail anyway, but you know how it is. You got to try it out. This dot underscore student ID, right? And we'll do that. And then underneath the next line, output, just to make it more human readable, plus equals to, here's our courses, right? So courses, this is wrong. And let's add in there maybe some kind of, some \n. So for some new lines, right? Because otherwise we're going to just write on top of each other. It's going to be one big line. That'd be bad. And the same thing goes here. Courses with a \n in there as well. And then another output line. We could have written this differently, by the way. Another output line. Let's get rid of this. With some kind of decoration. I want to put some decoration. So my courses, if I have any. And underneath my courses, I want to put my iterator, right? So here's my output, and then plus equals to whatever it's going to be, right? But we're going to put an iterator just like this, my for each loop, right? Because that makes sense. I know Ravina's like going, oh my God, this is crazy long, right? Tom, finish already. I want to take a break.
You do get courses method?
I could do my get courses method, right? But I don't have a get courses method right now, right? I could add one for sure, my get courses, but this is my get courses, my toString really. So let's just do it. So let's say for each. If I go for each, and if I don't remember the long for loop, I can press Control Tab, and it's going to suggest an iterator like this again. So I'm going to double click. So I'm going to say for course in courses, this dot underscore courses. Here it is. You guys taking off? Take care. And this is the loop that I'm going to put in there. And what I'm going to do is I'm going to say, I'm going to loop through each of these things, right? And I'm going to print out the courses underneath each one. So I'm going to say, so for each course, so I'm going to say output plus equals to, right? And then the name of the course, oh, sorry, course dot get name, right? Course dot get name. For now, all I want is a list of courses, not details. Like if I want details, I would have to get more getters in on the actual course itself, right? So course name is get name, right? Plus a \n, right? So for the new line, right? That's what I'm gonna add in there. So for each of the courses that I have in, so it's gonna go through each of my courses and spit out my course and a new line. That's what it's gonna do, right? And then I'm gonna probably take this decorator again and close it off just because I want to do that. Just kind of one of these decorations thing, right? All right, so that's that'll do it, but there's a problem. What if there's no courses? Will it loop through here? Right? And if there's no courses, I don't want them to even do any of this stuff, right? So, because that would just waste a lot of space. So I want to try and do an if statement. So if, how do I check the course's length, Ravina? This dot, let's say courses dot size, right, is less than 1, right? Then I'm going to do something, right? Here's something it says dot size, the field quick fix dot size is what I want to do. It's a method, not a property, right? If this course's dot size is less than 1, then I don't want to do that. I don't want to do this stuff. So I don't want to check for less than 1. I want to check for greater than 0.
Or is empty.
Right? What's that?
Is empty, I think.
Is empty. I could do that too. If courses is empty, then don't do it. If not courses is empty, then do it. I could just check if it's just like greater than 0. So I'm going to do it this way. There's definitely different ways you can do the same thing. So I'm going to kind of go in there and then do one of these, right? So I'm checking to see if the course size is greater than 0, and if it is, do all this stuff. If it's not, it's going to avoid it all. It's just going to print out my student ID. So that's a really much better toString method than I had before, right? Would you agree? Better, more control. right, than I had before. All right, lots of stuff. Yes, you good? You don't know what I did?
So lost. So I'm trying to catch up.
Okay, how about I pump it up to GitHub, and then so you guys are all on track. So I'm gonna go. I added a bunch of stuff. Actually, let me test it first before I do the GitHub thing, right? So testing is important. So I'll go here. Yeah. Here, are you good? What did I add in? What? Why did I add the check-in? Because I don't want to print out some stuff. So for example, I wouldn't do this if I go back to student. It won't do this here, this piece, because if it's not 0, it won't do this. But it'll still print this out and this out, right? I don't want to print those out unless it's a greater than 0. That's why. I want to format. I want to change my format. That's all I'm doing. It's just I don't have to, right? Otherwise, I'm still always going to do this, and I'm always going to print out courses. But if I don't have any courses, I shouldn't print that out at all, right? I don't have any courses right now. Okay, I could also put courses as 0 or no courses. I can do whatever I want here. But for now, I'm making it so it's easy. All right, let us run this thing and see what I get. Okay, so here it is. So I got programming fundamentals, right? Here it is, courses with programming fundamentals. And here's my mic. Oh, see, my student ID. I could have student ID. Mic. Oh yeah, I probably should have added a space in there. Let's try that again. Yeah. Student name Mike, student ID, blah, blah, courses, programming fundamentals. Let's add one more course in there. So in my program, let's add another course, not onto, instead of just programming fundamentals, let's add in, I also have some other kind of course on maybe 102, which is, programming design, first UML course. I don't know. The same cost because they're all the same cost. What was I say, right? And let's do this one. So I'll have both of them, right? So come in. So I've got programming fundamentals and programming design. So it looks like it's working. So my iterator works. And you know what? What happens if I add a course and then I drop? You know what? I added and I dropped the programming design course. I drop it and see if that works. That would be my check, right? Programming drop course, and I want to, my course name is programming design, right? So I'll say programming design. I drop programming design, and let's see if it actually shows up here anyway or give me an error. I want to check this out. So boom, yeah, that's what I was thinking of, right? It says exception in thread main, student.drop course, right? So it's a concurrent modification exception, right? So I'm adding it here and I'm dropping it after, and then it's not, my drop isn't working, right? So that's a problem. I knew that might happen, right? So what do you recommend, Ravina? How about Tyler? Tyler, what do you recommend? So my drop course didn't work. Give me a exception. So I said, here's my programming design. I dropped programming design. That's what I'm looking for. Remember, we did that going back to student. And what I did was in my drop, I said for course, if the course get name equals to course name, then remove the course.
You can't do that because you're iterating it over the array list. You can't remove elements.
I could remove an element. I can remove this, right? I could break if I find it. Huh? What, this? Oh, yeah. I don't know why. I think we left, it was a remnant of our last thing. I didn't see a problem there. Let's try it again, right? So, bam. So I removed it, but then it still does it. It says, exception in thread main, array list, here is this different. Iterator, check for co-modification in array list Java 901, right? And I want to go to iterator next at student.drop course, Java 23, this piece right here. So if my course get name is equals to course name, how about instead of removing it right now, we do a bit of a system.writeLine to see what's going on. So I'm going to go here like this, and I'll say system.out.println, and we'll print out the course that we're talking about, course dot course name, course dot get name. I want to just show, without removing anything, I'm just iterating. I want to see if I can iterate first, can do a comparison, and without removal. Let's see if that works. Yes, so that worked through, and I get courses. That's bad. This is what I get. Look, student name, and then I get, it didn't do anything. Look what it did. It goes for, here's my for loop, system.out.println course.getName, right? It didn't do this, course.getName. Right? See? So for course is, in this courses, if my course get name equals to course name, can I just not do this? What happens if I just do this? Equals double equals like this. Can't I do this? Course name. How come this will not work? Comparing, yeah. I can't use equals to strings. I could, but I'd have to yeah, it'd be I'm comparing a string with a string though. They're two strings. This get name is returning a string, course name is returning a string, and then I'm printing out the course dot get name, whatever my course is. Right? If course get name is equal to course name. So let me try this and see if it gives me an error. Right? So I'm trying to print out course name, and I'm getting nothing. Let me show you what I'm talking about here. Mike is eating. My 44th Street, I've changed addresses a couple times. My programming design, oh, there it is. Look, programming design, so I'm getting it now. I'm actually getting it, programming design. I didn't get it before. So it looks like I can do a comparison, right?
You can't remove it.
Oh, I can, by just doing this. I mean, I did my comparison, and now I remove the course. My course itself, right? I'm checking for each course is of type course and removing it as an object that I'm searching for. Let's see if I can do that. Will I iterate? Right? That's the problem. Can I pop a thing off here when I'm iterating? And that's the problem. Right? So as I'm iterating, can I remove something that I'm iterating from? Or do I break? Do I mention can I read the index of in another variable and pop that item out of the list later? Like for example, I could create an item, a variable called int, let's say index, call index. And if this is true, instead of printing out this name, right, course.getName, right, instead of doing this removal, do it after, right? So we'll say index is 0, right? Index is equal to 0. By default, index is equal to 0. But let's just say index is equal to 0, just to initialize. So I'm going to go through and then say, if this is true, if it's equal to course name, then index, we'll do this. Index then is equal to course dot. And I get the index of my course in my list, or this dot. Courses dot index of the list. So that's what I want to try and do, is index of course. Index of course. So the course that I'm looking at, give me the index and put it into the index. Don't do this yet. Do it not in the iterator. I want to do it down here. Right? When I remove at index. So one of those kind of, another thing altogether, that remove at index. Like remove at, and which would be the index name, right? So index. So this course is remove at index if this value is not -1, because I'll start it off at -1. So if index is greater than or equal to 0, because if it's 0, it's the first one, right? Then I want to remove my course at index. Ooh, let's see if that works. So I'm not iterating anymore and removing. Let's try this out. Bam. No, it works now. Okay, it works now. Okay, so what did I do? So my problem was I was removing while I was iterating, which I can't do. So I'm iterating through the course and I'm popping it out. Now my for loop is incorrect. I could have used a different syntax. I could have used a different iterator, a while loop that loops through by going to the next index, right? But what I've done here is I've used a for loop, a for each loop, that basically, or an enhanced for loop that searches through each of my each list element in my array list, and if I pop it out, if I do this remove while I'm inside the for loop, it gives me a kind of an index out of range, because now I'm searching for something that I've removed. That's what it's called. So it's a bit of complexity, a little bit of an algorithm here, but now it works. And I can do my drop if I want to. And just to show you that I can do this, if I go back to my program, I'm going to put up on GitHub in a second. If I wanted to remove it, the other one too, let's move the other one. So students dot drop course, and the name is programming fundamentals. I should have listened to Ravina. I'm killing myself now. Fundamentals, because it's course code is easier. Programming fundamentals. I want to kill this one too. And then if I run this, I should have no courses, and I should only show my student number as normal, right? And if I take them out, because I remember in my toString, I've taken those off. I take these both out like this as my test function, and I run this, I should get both, right? So if I run this, I should get both, right? So both programming fundamentals and programming design. And one more, if I, we kind of went off on a little bit of a tangent right here, but it's okay. It's good. It's good practice. Programming design, programming fundamentals. If I go into, I want to get rid of fundamentals, but not design, just to show you that it'll get rid of the second one in the list that we added. And I run this thing, then now programming design is there, but not fundamentals. So I kind of did both of those. So that add drop thing totally works. I know it's confusing, and I know it's pretty fast, but I'm going to go here and update to GitHub so that way everyone has what I have. So I'll do a commit, and I'll say, and I added these three things right now. So I'm going to say added several classes, including student and course class. Commit. Okay, you guys have it on GitHub now. Poof! We didn't talk about polymorphism. We did some interesting stuff here, but at the end of the day, what we did was we created a much more complex student class, which is a subclass. Say that again.
What if you just enter the first part of the name? Like this programming.
Just programming by itself. Okay, let's try it out. Now you're just wasting my time again. Let me just try this out. But okay. Student dot drop course, and we're just going to say programming. Does it drop both of them? Is that what you're saying, right? I think it just will break. Okay, that's what happens. Drops both. I mean, drop both.
No, you still have the in there.
Sorry. Let's see. Maybe I'll drop the first one. I'm only doing one deletion. Up. And nothing. Yeah, because programming and programming fundamentals is not equivalent to programming by itself. I'm comparing. I'm doing a string comparison. Two strings I can compare. Okay. So what I wanted to do, and I guess I don't have time to do it with student and teacher. I've got a teacher too in here too, but I'm not going to go into it right now. But the student is interesting. I want to create here's one thing I want to do for polymorphism. Let's change my person class and make it an abstract class. Can I do that without changing anything? So if I just said, public abstract class person, like this, does that change anything? If I was to run this thing the way it is, does that change anything? And the answer is no, right? It doesn't really change anything. But here's one thing that why this works. Abstract means that this class person will never be instantiated into an object. It's really a blueprint of a blueprint more than anything else. So I'm using person to create my person my person class as just a blueprint of a class that I can use, right? Okay, cool. What would be a proper interface that I could use, right? And interfaces would be almost like I want to create something that all classes, almost like it gives me a structure for my classes to follow. For example, I want both my student and my teacher to have something. So we can create an interface. Let's try this out. Let's say both of my student and my teacher has a specialized ID, like a school ID or something like that, right? And both of them have to have that in order for them to be a proper student and teacher class. So a school ID. Let's try this out. So I'm going to go into here into my default package, right click, and I'm going to add in, right? So I'm going to say new, follow me here, Ravina, interface, new interface. If I do a new interface, it asks me for my package and everything else, but I'm going to call this interface like a school ID or something like that. So I'm going to say all of my objects that I have this new school ID interface, right? It's a public school ID, and I'm going to press finish. Okay, here's my school ID. It's just looking like this interface. I have to use my interface keyword, just like we do in C#, pretty much, right? Now remember what we did in C#. It creates a shape for my object that I want. It forces me to use a certain shape for my classes to further constrain, to create a constraint, so that way I have to form my objects in a certain way. And I do that because sometimes I have very complex objects, and I want everyone to conform to a certain thing, especially if they want to consume the data from another object. Okay, so let's try this out. So here's my school ID, and I know that I want to have a school ID in here as a private variable. Now, can I make my interface members, can I make them private? Can I do something like this? Private, and then, I'm going to make it a string, and we're going to call this a school code. Let's make it a little different. Can I do that? Right? School code. And if you notice, it says one quick fix available. Remove invalid modifiers. It says illegal modifier for the interface field school ID. Only public, static, and final are permitted. Right? Why? Because, and of course, private wouldn't work, because we're making it so that the interface itself is being consumed by other objects, right? Even this public, if I take this away, if I say it's public or private or whatever, I've got to be very careful. Here's the other thing that I put in. If it says the blank field school code may not have been initialized, right? How come I have to initialize my school code here, right? School code is, and it's kind of in blue too, my school code, right? My string is school code. Do I initialize it like this? Is that what they're looking for? And the answer is, I'm just initializing with the base value. So string school code. So now there's nothing here, right? I mean, it's a public interface, but I want to make sure that every one of my teachers and students has a school code attached to them. So what do? I can go back to my student, and on the top where I inherit extends resident, I also can add the implements keyword, just like we do in C#. I implement, and if I want to start typing, it would be school ID, right? If I press Control Space, it'll suggest it, school ID. Okay, let's see if this runs now, and let's do the same thing with teacher. So resident, and then implements school ID. So we're going to start typing and then press Control Space, school ID. All right, now let's run it, see if it runs. Bam, it still runs. Okay, cool. Well, how come I can run it, right? And my interface, which I just wrote, right? So I'm just going to get rid of this for a second. Here, let's get rid of the outline. And of course, I've totally killed my view. So let's go back into my Java perspective. Reset. What I meant was, I have my my new ID, right, which is school ID. That's my new interface called school ID, and it's a string of school code, right? But I'm trying to implement it, but yet it doesn't care. I don't need it. I don't need to have it there. How come? Well, interface rules are a little bit different in Java. Let's go back here for a second. So we talked about polymorphism and how I can use the override keyword, and we've kind of done that with our toString to death, right? All I'm doing is creating additional, here's my abstract classes, and abstract classes are incomplete, it says. They're not really concrete classes. We have to talk about the difference between concrete and abstract. Concrete means a class that's done, right? It's not an abstract class. I can instantiate it. This one, an abstract class, is not concrete, which means I can't instantiate it, right? So that's one thing to know about abstract classes. They just talked about concrete, non-concrete. All right, so I can have abstract methods. We didn't really talk about abstract methods. I could include something that I want to override. In all abstract methods, you must override. Okay, that's one thing that you need to know, right? I'm just gonna go into interfaces here for a second. So I want to just drop into this section about interfaces, because we want to get right back into the, here we go, creating and using interfaces. So when we start off, it says the company involved wishes to perform several accounting operations, and then both operations have to do with obtaining some kind of payment amount, right? Earnings and stuff like that. And then interfaces offer the capability of requiring that unrelated classes implement a set of common methods, or not just common methods, but common controls, if you will, right? So let's take a look at some of these. It says interface declaration. All interface members must be public. That's why I was just showing you there. You can't make it private or protected, right? Because they're the widest level of access modifier. And all methods declared in interface are implicitly public abstract methods. That means they must override, right? All fields are implicitly public, static, and final, right? That's why I had, as a field, I had to set up this, this default, right? Public, static, and final, which means every single one of them, if I set up a student ID, as an example, going back to my interface, this student or school code, every one of my classes now that I've implemented it, both my teacher and my student have a public school code field that's part of them, right? So let me show you that. So if I go back to my student, because I implement school ID, and if I want to show my school ID down here inside my toString, I should be able to access it by going like this, because it's public. So I should say system.out.println, and if I say this dot school code, take a look, it's there, right? The school code is public and final, public static final, which means every single one of my objects has it. If I make it if I make it a field, but I don't want to make it a field. I want to make a method that everyone has to have, right? So I want to make something a method. That's kind of a better thing to do. Here's my school ID. That kind of adds in or updates my school code, if you will, or my ID, right? And I need to make that. So I'm going to say, let's get rid of my public static method, and we'll make this a public returns void, and it'll be I'm not going to define the body of my object, just like we don't do in abstract classes, but I'm going to say that everybody that implements the public interface school ID also has to have an add school method. Okay, so that's my abstract class add school. All right, now I got errors. Ooh, now I got errors. Look at the errors that come up. So here's my student Java, and this is what I was expecting to happen, right? It says, if I hover over, it says, the type student must implement the inherited abstracted method school.addSchool. So let's add unimplemented methods. Take a look. And when I do that down on the base here, it adds in this add school method, and with an override. That means I'm going to add a school, right? Now I could actually put in here in my private variable, kind of a couple private variables, private string. And I could put in there something like school ID, but now both of them starting to look, very similar. School ID, right? Here's my school ID, string. I'm gonna do the same thing for teacher. So because teacher has school ID as well. And if I add my unimplemented method, let's take a look at that. So I'm going to say, I'm going to kind of hover over, right? And it says add my unimplemented method, which is with an add override decorator, right? Add school. So what it's going to do is I'm going to update the school. So I'm going to say this dot school or whatever it's going to be is equal to whatever the school I want to put in there. The add school method is, I haven't defined it as anything, right? So let's say if I go back to my school ID for a second before we end off for today, maybe I want to take in the school ID will request a school name or some kind of a name that I want. So a string with a school name, school name. There we go. All right, so that's what I need. Now I've got another error, right? I'm going to kill these overrides for a second. Go back to here because they're the wrong signatures. Let's use my quick fix again. So I'm going to hide over here and add unimplemented method, which adds my school name. That's good. And the same thing goes with our teacher. So I'm going to add my unimplemented method, my teacher, that adds my school name with the at override decorator. And what this means is I got to override or declare what my method is for each of my objects. So, so then it's going to be like this: this dot underscore school ID, right, is equal to school name. So I really want to do. I want to do the same thing here and here. Now you might say, hold on, this is like you could have created an abstract class to do that, but instead of creating a whole abstract class, because I have an abstract class called person, right? Instead of creating a whole abstract class, I can just include an interface like school ID that just talks about the method signature. That's the method signature. And this is what polymorphism is all about. There's two pieces. One is I can override abstract methods or classes. And two, I can create an interface that adds on to my the class that I'm inheriting by adding in additional methods. Right? So I can further specialize my class. So I've got my class, my parent class is person, my super class is person, my direct super class to each of my teacher and my student is resident. They don't have any of those methods. They don't have a school. They may not, residents may or may not go to school, right? There could be a person who's done school. They're not a teacher or a student, they're a worker, right? So they don't need the school ID in there, right? But I want to be able to add my school ID by specifying the school, and I have to add this method into both, right? So I force, that's what my interface does. It gives me, I'm forcing the shape of both my student ID, my student, and my teacher to have this additional method, right? So when I say forcing the shape, I'm actually making them have this extra little container called add school, which is another method. It's exactly what we learned in C#. Now, I know we kind of went down a tangent with that, add courses and drop courses, all because of Ravina. It's all her fault. I have to blame. It's actually my fault. I'm the one that kind of said, okay, we'll do that. I should have said, no. We don't have courses. We just want student and teacher. And that would have been done like an hour ago. But actually, this is a very good thing because what I've done is I've kind of talked at length about array lists, which we kind of mentioned, but it really didn't kind of do. So I kind of handled it today as opposed to the other day that we had them. Any questions around this? And I'm going to go up on concept board just to see if there's any other issues. I'm going to just wait a second for people who are remote. There might be somebody who can pop into concept board if you're watching and go and ask some questions. But really, this handles everything. If you look at the PowerPoint, the good thing about this or the PDF is it really details how to put together abstract classes and interfaces. We're going to need to do some of this when it comes to UI. UI requires you to override methods that are part of the built-in functions for our JPanels and all this other stuff, right? So we're going to need to do this in the next section we handle for UI, and I'm going to give you your next assignment, which is going to be about classes and polymorphism and inheritance and interfaces and all that kind of stuff. I'll try and do it before the break, right? I'll put a little video up that's separate from this class that says, hey, here's my assignment number 3. And for those people who are watching, and I'll post the assignment number 3 up online as well in eCentennial, and you'll have a chance to work on it over the break, but it won't be due until the week after the break, like on exam week. Okay? Any questions? And that's it for today, ladies and gents. Well, let me go back to concept board to see if anyone else added a question.
How do you know like when to use abstract class and when to use interface?
How will you know when to use classes and when to use interfaces?
Abstract class.
So why do you think you would use? That's a good question. So why would you use an abstract class? I know we're running a little bit over. Why would I use an abstract class as opposed to just a regular class? So I made an abstract class called person because I never intend ever to instantiate my class. That's the first reason why I want to use an abstract class. It's almost like a blueprint to the blueprints. I want to create a class that I want to derive other classes from, right? That's one thing I want to do.
The parent class is abstract class.
The parent class is an abstract class. That's what I did. My person class is an abstract class, so that way my resident, I never will instantiate an object of the person class, but I will instantiate an object of the resident class. Now I could take it one step further. I can say, well, resident doesn't make any sense. I can even make that an abstract class, right? Because I can say person is really abstract. It's really high level, so I might as well make that abstract class. I can make a resident an abstract class. Let's try that. And my only concrete classes in here right now are student and teacher, right? So let's try that out and see if it gives me an error. So I'm going to go back to just close some of these off. It's my course. Here's my resident. And right now my resident is a regular class, right? Because it extends the person class, which is an abstract class. Let's make this one an abstract class. I'm never going to do this one. It makes sense. So public abstract class resident, right? And if I run this thing again, by running, it still works because if you notice, I can still instantiate my student object because the student is a concrete class, and both my resident and my my person classes are both abstract classes, which makes sense. So it's all part of our business rules, Ravina, right? If it makes sense to me to instantiate objects, I'm going to make them concrete classes. If I'm using them as blueprints, I'm going to make them abstract classes because I'm never going to ever instantiate them. And a good example of that would be if I make a game, right, and I have a generic game object, right? Do I ever really want to instantiate a game object, just generic one? The answer is no. I have a blueprint for a game object, but maybe I want to make another one. The game object is actually going to be a button, or it's going to be a camera, or I'm going to put it together as some kind of a spaceship, or one of those, a sprite, something. But if I just say game object is too generic, and even further than that, an object would even be further generic. I'm never going to instantiate those objects, so those would be good abstract classes. Interface, what it does is it adds on to our abstract classes. So for example, resident, like I was saying, right? Resident is an abstract class. Student and teachers are both residents, but they also need to be part of a school, right? But there are some residents who are workers that don't need to be part of a school, right? Yes.
You can also only extend one class.
Correct. I can only inherit from one. That's the rule. It's only single inheritance, like I said. But I can implement more than one interface, right? So for example, and each interface can have its own methods attached to it. So to make it more, I can make a more specialized subclass, right? Based on my two abstract classes and some interfaces to make it. So for example, this is what I did. I made a school ID because teachers and students can be, are still residents, but they're specifically go to school. But there's other residents who are workers who don't go to school, and they wouldn't need that extra method. And that's why I added it in, right, as an interface. That's a very simple, silly example, but the thing is, it works, right? And that's how you have to think about it. If there's something that I want to add an additional method, but you know what? It doesn't make sense to add it to all of them. An example of that would be this. I want to make a game object, right? But I don't want all game objects to have some movement capability. Not all game objects I can control with a keyboard and mouse, right? I want some of them to have that, but not all of them, right? I can inherit from multiple classes, but I want to have all of them as a game object. So when I do a game object check, is this a game object? Yes, they are, because it's an is-a relationship. They're all game objects, but some of them are specific game objects that move. So I'm gonna give some kind of movement capability, the movement interface, to some game objects, but not others. And the way I can do that is by implementing interface. right? So buttons would be a game object, but spaceships would be also a game object, plus they would implement a movement interface. Make sense? In my game framework, right, that I'm making, not Unity. Make sense? Because that's better. Buttons and labels don't move around, but a spaceship would. It's still a game object, but it has movement. Okay, that's it for me. We'll talk more about this when we come up to it. Again, the PowerPoint's very good from a backwards, and you should already know this, by the way. This is all the stuff we covered in COMP228. What was that?
Gets a bit confusing.
I know it's confusing, but it gets easier when we actually do. All right, and we'll come back. Again, no teaching week next week. We'll come back, and I'll try and produce an assignment before then.